x prime t equal to a times x. Here xt is the vectors function x1 of x, x1 of t, and x2 of t. T is a term, it is a real number. x1, x2 function with variable t. A is a 2 by 2 matrix with real entry, so 2 by 2 real matrix. We use the eigenmethods, the eigenvalues methods to solve that. So there are this many possibilities. The first case we have two eigenvalues, say two distinct eigenvalues, lambda 1 say negative, lambda 2 a positive. In this case you would have a saddle point. The general solution is of the form xt equal to c1 v1 e lambda 1t. v1 is the eigenvectors correspond to the eigenvalues lambda 1 plus c2 v2 e lambda 2t. So let's do an example of the phase portrait. We first have the two axes x1, x2. So x1 and x2 corresponded to function x1 of t, x2 of t. You might ask, so where is t? Each value of t determines a value for x1 and x2. Say x1, x2 are just a curve. For example, here's a curve x1, x2 on the plane. At the point t, say equal to 0, at the time 0, the point here. When t is go to infinity, the curve will go from the time 0 to infinity. The other side is t minus infinity, correspond to t is 10 to minus infinity. So the curve would go like this. It goes this direction. So depending on the value of t, for example, at the initial time, at the time 0, maybe the point is here. So for t equals 0, the vectors x0, x1 0, x2 0 correspond to this point. So this would be x1 0, x2 0. And then depending on how these go, is follow the eigenlines. So let's look at this case, lambda 1, lambda 2. Let's do an example where lambda 1 is negative, lambda 2 is positive. Say lambda 1 is negative, minus 1, lambda 2 is positive, say 2. Correspond to lambda 1, v1, say vectors 1, 1, and v2 vectors minus 1, 2, for example. So v1 minus 1, 1, minus 1, v1 is on 1, so 1, 1. So v1 give us these vectors. Now these vectors give us the whole eigenspace in this line. And along this line is correspond to v1 1 here, and v1 is eigenvectors correspond to lambda 1, which is negative. So the solution e lambda 1t, so e minus 1 times t, this one tends to 0, e lambda 1t tend to 0 because lambda is negative when t tends to infinity. Therefore, along the green line is go into the origins. That's the first thing for v1. Now say the eigenvalues v2, the blue one, vectors v2 minus 1 minus 2, minus 1 2 minus 1 is here and 2 is here. Vectors minus 1 2 is these vectors. This gives us this line. Along this line we have v2 times e lambda 2t, e lambda 2t. So lambda 2 is positive, lambda 2t. When t tends to plus infinity, this one tends to plus infinity. In this direction is go off infinity. So here's how we can see the time t, for example. We know that when t go to infinity, it go to the future, it go like this, it go into the origin. So we know that, for example, in this corner, this part, t go to infinity. For that mean it just go like this for this point, starting here, follow this. T still go to infinity. It's still going to infinity, and then it's approached by. So the time just go until here, and then because now we are close to the blue one, it's influenced by the blue one. We follow that. So the red trajectory look like that. In this case, we have one particular solution, similar for the other case. And then let's go like this. Here's the first example when we have the saddle point. Origin is a saddle point. Let's do the second case. The case now where both of them are negative. Case 2. Lambda 1 and lambda 2 are both negative. Let's say lambda 1 is less than lambda 2. Now because eigenvalues are distinct, we still have two distinct linear independent eigenvectors v1, v2. We get the plane. x1t and x2t. Let's say x1, x2 for the two axes. We have v1, v2. For this example, let's do v1, 1, 1, v2, minus 1, 2. 1, 1, this vector, so the z was this line. Along this line, solution now, general solution, xt c1 e c1 v1 is lambda 1t plus c2 v2 is lambda 2t. Both of them are negative, so it will go to infinity. When t go to infinity, it's go to 0. This one will go 0. So along this line corresponds to v1, it will go to the origin. So in this case, at least you know that t, when it go to plus infinity, it will go this direction. Though, for example, in this line, say t equals 0 is here, but when t go to infinity, it's go like this, and t is in this side correspond to minus infinity for the time. Now this is v1, we have v2. v2 minus 1, 2. Minus 1, 2. So we have these vectors. Extend this. We have the blue line. And again, because lambda is negative, lambda 2 is negative, e to the lambda 2t tends to 0. Now, let's draw other trajectory. Assume that if we are in this corner, at the time 0, we are here. Now, where do we go when the time go to infinity or the time go to minus infinity? When the time go to infinity, we do know that it is this need to go into the origin, because time go to infinity is this line will go on to the origin. We know that we need to go to the origin when these go to infinity. But which one is follow? Which one is dominated by? So here's v2. v1 corresponds to lambda 1. Lambda 1 is less than lambda 2. Lambda less than lambda 2. This go to infinity. In particular, this is positive. If we multiply t, we get some inequality still. Lambda 1 times t less than lambda 2 times t less than 0. E to the lambda 1t will be much smaller than e to the lambda 2t. This one decays so fast, this one is bigger. So when t is tend to plus infinity, the one correspond to e lambda 2t will dominate. The one correspond to e lambda 2t is v2. So it's follow v2, follow the blue one. The solution xt follow, or you can say parallel to v2 when t go to infinity. So this is our first observation. It has to follow v2 when it go to infinity. follow V2. So somewhere like that. When it's close to infinity. Same for the other, or 3 other corners, close to the blue one. To the blue one when t go to infinity. What about when t is minus infinity, for example? For this case, we know that this one need to move closer and closer, follow V2. The other side, we expect is follow V1. Here's how. Lambda 1 less than lambda 2 less than 0. Now, when t tends to minus infinity, you multiply t. In particular, t is less than 0. When you multiply t, you have lambda 1 t is bigger than lambda 2 t, bigger than 0. So, exponential of that, lambda 1 t will be much bigger than exponential lambda 2t. The one dominant will be the one with lambda 1, the one with v1. So it's follow v1 when t is minus infinity. So solution xt follow v1 parallel to v1, t tends to minus infinity. So minus infinity is follow v1. So that what happened. Far away from the path, and infinity from the path, just follow v1. Now we just join them. So the curve should look like this. And you do the same, you have a few other solutions. So that's the idea. The other, or 3 other signs, you do the same. When t is minus infinity, it just parallel to the green one. Eventually just approach this line, the line of V2. Same here, parallel to the green one. And then I'll follow this. The last one is, let's go like this. In this case, we have a sink, so nodal sink, and it is improper. Because virtually all of them tangent to this blue. That is the second case where we have negative, negative. Positive, positive will be similar. Now what about, we can try one. What if the case where lambda 1 is bigger than lambda 2 and bigger than 0? Say v1, v2. Assume that v1, v2 can be drawn like this. v1 correspond to this line. v1 lambda 1 positive. v2 correspond to this line. So lambda 2 also positive. x1 here, x2 here. Because both eigenvalues are positive, it has to go off infinity. The second observation, we see that solution, we know that xt is c1, v1 is lambda 1t, c2, v2 is lambda 2t. Now v1 bigger lambda 1 bigger than lambda 2, t tends to infinity. In particular, t is positive, lambda 1t bigger than lambda 2t, and in this case exponential that much bigger than exponential of lambda 2t. This one dominates. When t tends to plus infinity, is follow the solution follows v1 parallel to v1, so parallel to the green one. So when t is go to plus infinity, is parallel to green one. Similarly, we can do that when t go to minus infinity, we could expect x follow the blue one. Lambda 1 bigger than lambda 2. T tends to less minus infinity, t is less than 0. Lambda 1t is now less than lambda 2t. This one bigger than 0, this one less than 0. Is lambda 1t when decays very fast, much smaller than is lambda 2t. So the one dominate is this one, the one bigger. So it's follow v2 or xt parallel to v2 when t tends to minus infinity. So as soon as we start from this point, initial condition give us this point. When t go to plus infinity to the future, is we know that's all go of infinity is go to the future, parallel to v1. Okay, so good is parallel to to V1. And when t is very, very small, this tends to minus infinity parallel to V2 or very close to V2, with tension to V2 in fact. So just follow V2 when this is minus infinity. Yeah, so the curve looks like this. Draw a few of them so it will look like this. Similar, you do the other side. Very close to V1 when it is negative, and parallel to the green one when it's positive. So it goes like this. Same for the other two sides. And in this case, you see that everything go up infinity is a source. Improper, nodal, source, origin.